Have you ever looked up at the night sky and felt like the universe was whispering secrets, just out of reach? Well, now it's screaming at us. This is a cosmic mystery so profound, it's shaking the very foundation of modern physics. This is the moment we might have to question Einstein himself. This is what happens when the most powerful telescope ever built points at the edge of the universe and finds something it shouldn't. Today, we dive deep into one of the most mind-bending discoveries in astronomy. Why is our universe expanding faster than it should? What did the James Webb Space Telescope just reveal that's blowing scientists' minds? And why are some physicists seriously considering rewriting the rules of gravity? Stick around, because this isn't just a video about stars and galaxies. This is a front-row seat to the unraveling of our cosmic blueprint. A century ago, Edwin Hubble looked into the sky and saw something extraordinary. Galaxies, entire collections of billions of stars, weren't just out there. They were moving away from us, all of them, in every direction. It was the moment humanity realized that the universe is expanding. Fast forward to today, and that balloon, it's not just expanding, it's speeding up. That, in itself, is already weird. But what James Webb has just confirmed, it's something else entirely. It all started with a number. A simple, elegant number that was supposed to tell us how fast the universe is expanding, the Hubble constant. Physicists believed this value should be around 67 kilometers per second per megaparsec. That means, for every 3.26 million light-years you go out into space, galaxies should be moving away from each other 67 kilometers faster every second. But reality, it doesn't care about our predictions. To settle the debate, NASA turned to its most powerful eye in the sky, the James Webb Space Telescope. With its unmatched precision, JWST studied stars across the universe, focusing on red giants, Cepheid variables, and exotic carbon-heavy superstars. And what did it find? The exact same numbers Hubble did. 2 of humanity's best telescopes. Across decades of data. And the result is clear. The universe is expanding faster than our models can explain. This is not a rounding error. This is a scientific crisis. So, what's going on? To explain the accelerated expansion, scientists invented the idea of dark energy, an invisible force that acts like gravity's evil twin, pushing everything apart. But what if? Dark energy isn't the answer. Nobel laureate Adam Rees says it out loud. The discrepancy suggests our understanding of the universe may be incomplete. This is where things get wild. Some scientists believe we may have misunderstood gravity itself. Yes, gravity, the very thing Einstein reshaped over a century ago. A group from the universities of Bonn and St. Andrews is proposing something radical. We might be living in a super void, a massive bubble of nearly empty space. Imagine biting into a loaf of raisin bread, only to discover you're sitting inside a giant air pocket where a raisin should be. This is what some astrophysicists now believe. We may be living inside a massive cosmic void, a super void. You see, the universe isn't just a random scatter of galaxies. It's structured like a web, full of dense filaments and empty spaces. Think of it as a cosmic sponge, where matter clumps along strands and leaves bubbles in between. And according to these researchers, our Milky Way might be floating inside one of those empty pockets. If true, this supervoid would subtly distort how we perceive the expansion of space, because gravity in a void behaves differently. Galaxies near the edge of the bubble get tugged outward more strongly, making it seem like the universe is expanding faster than it actually is. This is cosmic illusion, on the grandest scale imaginable. So maybe the Hubble tension isn't a glitch in our models. Maybe it's just that we've been standing in the middle of a gravitational funhouse mirror all along. But there's a twist. According to the standard model of cosmology, supervoids shouldn't even exist at this scale. Yet, telescopes have found galaxies 600 million light-years away, racing off 4 times faster than predicted. That's not just odd, that's a cosmic red flag. What if we've been using the wrong equation this whole time? To explain the Hubble tension, most scientists stick to tweaking the ingredients of the universe, adding more dark energy, postulating exotic particles, or adjusting the early universe. But others, they go straight for the core, gravity itself. Meet MOND, or Modified Newtonian Dynamics. First proposed in the 1980s by Israeli physicist Mordechai Milgram, MOND changes how gravity behaves at very low accelerations, like the edges of galaxies, or inside vast cosmic voids. Instead of adding dark matter or dark energy, MOND rewrites how motion works when gravity gets weak. This is the punk rock of astrophysics, ignored by most, dismissed for decades, but suddenly, strangely relevant. Why? Because MOND doesn't just explain galaxy rotation curves without dark matter. It predicts the existence of supervoids, exactly the kind of massive bubble we might be living in. According to MOND, gravity behaves differently inside these empty regions, making the universe appear to expand faster when measured from inside. This is the part where MOND starts to sound not so crazy after all. In fact, some simulations show that if MOND is correct, the whole Hubble tension could vanish. We wouldn't need 2 conflicting expansion rates. We'd only need 1. In fact, some simulations show that if MOND is correct, the whole Hubble tension could vanish. We wouldn't need 2 conflicting expansion rates. We'd only need 1. That's elegant, that's powerful, but it comes with a price. Questioning Einstein is like walking into a cathedral and asking if the ceiling is upside down. It's bold, it's blasphemous, and yet, that's exactly what MOND dares to do. Einstein's general relativity has passed every test we've thrown at it, predicting black holes, gravitational waves, the bending of light. It's one of the most successful theories in science. But there's a catch. It only works if we assume dark matter and dark energy, 2 things we've never actually seen. This is the paradox of modern physics. We trust a theory that requires 95% of the universe to be made of stuff we can't detect. MOND challenges that. It says maybe there is no dark matter, no dark energy, just a misunderstanding of gravity at the deepest level. But here's the problem. For MOND to go mainstream, we'd have to rewrite major chunks of modern cosmology, toss out equations taught in every physics classroom, rebuild the cosmic model from scratch. And it's not just Einstein. We'd be challenging decades of observations, models, and simulations, all based on assumptions MOND contradicts. It would be like replacing the foundation of a skyscraper, while still living in the top floor. This is the risk, but also the reward, because if MOND is right, then everything fits. The Hubble tension, gone. Supervoids, expected. The need for mysterious invisible matter and energy, reduced or eliminated. And that's why, despite the controversy, more scientists are starting to pay attention. So, where does that leave us? We've got two of the most advanced telescopes ever built, Hubble and James Webb, telling us that something is wrong. The universe is expanding faster than it should. We've got dark energy, a ghost force no one can detect, a possible supervoid swallowing our galaxy in gravitational illusion, and a rebel theory, MOND, whispering that gravity might not play by Einstein's rules after all. This is not just an astrophysics problem. This is a wake-up call. Because every time we think we figured out the universe, it throws us a curveball. And that's the beauty of science. It's not about being certain. It's about being curious. Maybe the cosmos is trying to tell us something. That reality is stranger than we dreamed. That physics isn't finished. That we're still students, staring at the sky, piecing together the puzzle. This is the edge of understanding. This is what it means to be human. Whatever the answer is, MOND, dark energy, or something we haven't even imagined yet, it's out there, waiting. So look up, ask questions, because the universe is listening. If you enjoyed this journey through the cosmos, consider subscribing. There's a whole universe left to explore.